All right, welcome back to Math 107. We are at Lecture 18A, and as it turns out, we've actually gone over the material where your test 3 is going to end. And I was just telling the group in here, when I was making up test 3 last week, I was a little concerned, didn't know how far exactly I was going to get. Should have stuck with the original schedule I had, but I'm going to end test 3 with 6-3 and 8-1, which was just solving those right triangles, and then we'll do 6-4 and then the curve sketching of the basic sine, cosine, and tangent curves that will also be included on the final exam. So before we jump into 6-4, I do want to make sure we are indeed experts on the trig that we have covered so far. Experts. And then I'll see what questions you might have about that. Okay, so I'm just going to call this a quick review. Just make sure we're good. Suppose that I tell you that you're given the tangent of theta equals 4, and theta is an acute angle. And you're asked to find the cosine theta, and the measure of angle theta in degrees. Okay, can you read that somewhat? We're going to be told that the tangent of angle theta is 4. Theta is an acute angle, and we're asked to find the cosine of theta and the measure of tangent theta in degrees. What would you do, everybody? There's several different approaches you could go here.
Measure of
Angle theta in degrees.
Okay.
Find how many degrees angle theta is. What kind of angle would have a tangent equal to 4? What is the angle? Does that tell you, is that a hint? What is the angle whose tangent is 4? All right, how do we start out with this to find what the cosine of this angle is? What would you do? Draw a little right triangle. That's a way most people would go about it. Draw a little right triangle. I can put theta either position, either angle, because I'm just using this as a little tool. I'll just stick it right here. And in terms of my right triangle, the tangent is defined to be the
two legs, or cosine over sine.
cosine over, no, sine over cosine. What else? Opposite over adjacent. A lot of times that is easier to think. Opposite over adjacent, and that's equal to 4. How do I write 4 as a fraction so I can do an opposite and adjacent?
8 over 2.
You can do it 8 over 2. Any kind of ratio that gives you 4 is good. 8 over 2. How about 4 over 1? That's about as easy as you could get. So if you were going to do opposite, this would be 4. This would be 1. And by definition, what is the cosine of angle theta defined to be? Adjacent over hypotenuse. The adjacent we can rewrite off as 1. This is adjacent to that angle theta. How do you find the hypotenuse, everybody? Good old Pythagorean theorem. 1 square plus 4 square equals c square. 1 plus 16 is 17 equals c square. So c is square root of 17. So the cosine for this angle is 1 over square root of 17. You don't need to rationalize denominators or anything. Just leave it like that. Okay? So once you set up your triangle, you can find all your other trig functions. If you know the tangent of theta is 4, what other trig function do you immediately know? Cotangent. What is the cotangent of this angle? 1/4, right? Okay, if you know the cosine is 1 over square root of 17, what other trig function do you immediately know? Secant, S-E-C. And the secant is square root of 17. All right, what is the sine of this angle? opposite over hypotenuse, which is 4 over the square root of 17. So if you know the sine, what other trig function do you immediately know? Cosecant of the angle, which is square root of 17 over 4. Okay, so I really harp on tangent, cosine, sine, because if you know those, you know the other three. All right, the next question is, well, how do you find the measure of angle theta? What is the angle? How are you going to use your calculator to find what is the angle? You're going to use your inverse trig function. And I would pick tangent this time because that's going to be the easiest thing to type in, so you don't have to worry about square roots. I mean, you can do it. It's still the same angle. All right, if the tangent of the angle theta is 4, in order for me to get theta, I'm going to have to find the inverse tangent of both sides, indicating that this is a composition of functions. The inverse tangent of the tangent, they undo what the other one did, and that's going to leave me with the theta equals inverse tangent of 4. And that really says, give me the angle where the tangent is 4. So now we're solving for what is the angle. So on your calculator, if we're worried about degrees, don't forget to go to your mode, and make sure you're clicked in on degrees. And then we'll just go inverse tangent. That little -1 just means inverse tangent of 4. And that tells me that theta is approximately 75.96 degrees. About 75.96 degrees. And I can check myself. Now if I go take the tangent of about 75.96 degrees, I get 3.9988857. So it's pretty close to 4. I was off because I rounded the degrees right there. Anybody have a question for me on that? Okay, your book is not drilling you so much on, if any, on what is the angle right now. But that is on your test. That is an objective. What is the angle? Okay? So be sure you're working on that. Can I answer a question about this problem?
Yeah, about the inverse tangent.
Uh-huh.
Explain that again, when to use it.
Remember that functions and their inverses, when you form their composition, they like cancel each other out. If you take a function and you put the number 3 in it, and then that answer goes into the inverse, you come back out with 3. So the inverse, this is really like forming the composition. I had tangent theta, but now I'm going to put that into its inverse function, and that cancels out the tangent with the inverse tangent and leaves me with theta. That's really just the composition. So an inverse trig function will say, what is the angle? Give me the angle. Okay? Now there's much more to an inverse trig function because there are restrictions on the domains, but we're going to use it as a tool to help us find some angles. Okay, we're just going to worry about the acute angles and using the inverse trig. And this course does not get into inverse trig functions. But there are restrictions on domains and all that stuff. There is more to the story than just what I gave you. Okay, but for right now, if you're looking for what is the angle, use your inverse trig function. That will give me an acute angle. All right, everybody good so far? Everybody can make 100 on that question on the test? Answer is yes. Okay. Next review question. Going to have a right triangle. I'm going to call this angle beta. I'm going to call this side B. Call this side alpha. This angle alpha, and this side A is 3, and the hypotenuse is 5. All right. Without any effort, can somebody tell me what the length of side B is from your days of geometry? 4. There are some special triangles, right triangles, that are the 3, 4, 5 right triangle. There's another one. What is it?
Crap. 5,
5, 12, 13.
Okay.
These are the hypotenuses right over here. The legs are 5 and 12, and the hypotenuse is 13. And of course, any multiple of that would also be it. But some popular triangles you see a lot are the 3, 4, 5, or the 5, 12, 13, they work. So you could use the Pythagorean theorem, and you would, of course, get b equal to 4 right here. Okay, but I'm interested in finding angle alpha. What is the measure of angle alpha? What are you going to do to find that?
You do the cosine.
Okay, you can use any trig function you want to from this triangle, and you're choosing to use cosine. Okay, the cosine of angle alpha is adjacent over hypotenuse, 4/5. So if I want to find the measure of angle alpha, what am I going to do? Everybody verbalize it. Inverse cosine of 4/5. Okay, so I know that I'm already in my degree mode. Inverse cosine, parentheses, 4 divided by 5. And the measure of that angle is approximately 36.9. It's 36.869. So I could round it to 0.87. It depends on how WebAssign is asking you to do some of these things. Excuse me?
I think I went to 2 decimal places.
2 decimal places? Okay, then it would be 0.87. Okay? So alpha then would be about 0.87. Now, you know that alpha and beta add up to how many degrees? 90 degrees. So if you know this one, you could easily find beta. But I gave you a warning the first day that it is best, in my opinion, to only use things you're originally given, because if you somehow messed up on angle alpha, then now you've messed up on angle beta if you use something you've come up with. All right, and we actually found the 4, so let's don't use that 4 when we're looking for beta. What trig function would you use to find beta?
Sine.
Would you use sine?
Sorry, cosine.
What does everybody think? If I don't want to use 4 and I'm looking from angle beta, is that opposite angle beta?
Adjacent.
That's adjacent over hypotenuse. So I've got the angle, the side adjacent, and the hypotenuse, so I will be using cosine, right? Cosine beta is 3/5. Okay, and so we have then that beta will be the inverse cosine of 3/5. The inverse trig function is giving you the angle. What is the angle? All right, inverse cosine, parentheses, 3 divided by 5. And so that comes out to be approximately 53.13 degrees. And those two angles added together come up to be pretty close to 90. Actually, they come right out to be 90, don't they? All right, when you add them together. Everybody good? Questions? Okay, quick drill on those exact values. You had some special angles. Special. Don't look in your notes. Special angles. I want you to think of 45 degrees. What's the radian measure? 3 pi over 4? Pi over 4. If you forget, what are you going to do? Divide this by 180? Just divide by 180?
Oh no, it's about the pi over 4.
To go from 45 degrees to pi over 4, what do you do if you forget? 180 over pi?
Pi over 180.
I want the degrees to divide out, don't I? So I need to do pi over 180. All right, pi over 4, that's a 45 degree angle. The sine, the cosine, and the tangent are all going to be easy for you to memorize. What's the sine without looking down? What is it? Square root of 2 over 2. What's the cosine? What's the tangent? Tangent? Tangent, remember, is sine theta over cosine theta. So if you say square root of 2 over 2 divided by square root of 2 over 2, it would be equal to 1. All right, suppose I ask you, what is the angle where the tangent's equal to 1? You know right away it's 45 degrees, wouldn't you? If I say inverse tangent of 1, that's saying what's the angle where the tangent is 1. Or you could say the tangent of theta equals 1, and you're going to know that that is 45 degrees. 45 degrees. Okay? How did I derive this last time?
With the right triangle.
A right triangle? What kind of right triangle?
45.
If I had 45, 45, what kind? Isosceles right triangle, so you knew these sides had to be the same measure. Okay. All right. Let's go to 30 degrees. What's the radian measure for 30 degrees? Pi over 6. Okay, pi over 6. All right. If you remember, we used an equal angular triangle, so 30 degrees and 60 degrees, the sines and the cosines going to have the same numbers, but you got to think sine is opposite. Sine is opposite. Okay, my choices for sines and cosines for 30 degrees and 60 degrees. Remember, 60 degrees is pi over 3. I'm not sure how you're wanting to memorize this if you're going to go the direction I'm sort of pushing you. Is you know that for sine and cosine, the answer is either a half or square root of 3 over 2. Which number is bigger, a half or square root of 3 over 2? Square root of 3 over 2 is bigger. And sine is going to be your opposites, right? And if you're on your small angle, the side opposite's got to be the smaller number. So for sine of 30 degrees, you would write 1/2. That means the cosine of 30 is square root of 3 over 2. 60 degrees, that's your big angle. So the side opposite it's got to be the big number. So that is square root of 3 over 2, which means your cosine of 60 is 1/2. I'm not sure how you want to memorize that. You got to memorize it some way or another. Okay, once you know sine and cosine, you immediately know tangent. Okay, the tangent of 30 degrees is going to be the sine of 30 divided by cosine of 30. What's that going to be when it simplifies? 1 over the square root of 3. And if you wanted to rationalize that, you could. All right, tangent of 60, sine over cosine. What's that going to come out to be?
Square root of 3 over.
Square root of 3. Okay? All right. Got those to memory, everybody? All right. Are we good to go? Any questions on what we did in lecture, whatever it was before this one? 17, A's and B's? All right. We're going to start section 4.6 today. Oh, I'm on the wrong page. 6.4. Thank you. Thank you. I'm in section 6.4. Thank you. And these are your trig functions of general angles. And I want to emphasize these are general angles in standard position. Standard position. Okay, there's some key terms that we're going to have to be comfortable with, and those terms are called reference angles. Reference angles. I'm just going to give you an overview. You're going to listen up for some of these things. Reference angles, reference triangles. Okay, reference angles and reference triangles. All right, before we start, we're going to just have a little fun with our calculator. We're going to look at the sine of 30 degrees. We're just going to play with our calculator. You already know what the sine of 30 degrees is. Say it fast. 1/2. Thank you. We're going to look at the sine of 150 degrees. We're going to look at the sine of 210 degrees. And we're going to look at the sine of 330 degrees. and we're going to look at the sine of negative 30 degrees and the sine of negative 150 degrees, and by then we'll be tired. Okay? All right. First thing I want to do, though, is let's make a little sketch which quadrant we're in. If we have angles in standard position, 30 degrees, we have a little triangle right here, a little angle right here. And remember, a sine is defined to be the ratio of the opposites over the hypotenuse. So as long as you've got this same angle 30 here, you can have a bunch of triangles. They're just going to be in common ratio. Opposite over hypotenuse or opposite over a bigger hypotenuse is just a ratio of that angle. All right, so we're just going to click away on, oh, let me draw where all these are. Where's the terminal? Let's start with a new page. This is looking a little bit close here. Okay. Sine 30 degrees. Okay, sine 150 degrees. Where's the terminal side of 150 degrees? Quadrant 2. And sine 210 degrees. Where's that terminal side? Quadrant 3. Okay, and we'll stop right here for the second, then we'll go to the next page. Okay, so when we're punching away in our calculator, sine of 30 degrees, we already know that's 0.5, but we're just, oops, not inverse sine. Sine of 30 degrees, there's our 0.5. And again, that just means that the opposite side to the hypotenuse could be 0.5 to 1. We could extend this, and we could say 1 to 2. We could continue to extend this and say 2 to 4. Everybody got that idea? Okay. All right, now let's do sine of 150. The sine of 150. And what did we get? 0.5. The sine of 150 is 0.5, which is the same as the sine of 30. Okay, this is where I'm going to bring in your terminology. This angle is 150, but to help me understand the words opposite over hypotenuse kind of deal, we're going to go to what is called a little reference triangle. The little reference triangle is going to use a reference angle which is always with respect to the x-axis. A reference angle is always with respect to the x-axis. Repeat that. A reference angle is always with respect to the x-axis. So it's going to be an acute angle with respect to the x-axis. What's an acute angle? Measures between 0 and 90, right? So this is going to be my little reference angle right here, and I'm just going to draw a little reference triangle. I'm going to call this theta r for reference angle. Reference angle. What is the measure of this little reference angle? If this is 150 degrees, what's the measure of the reference angle here?
50.
What is it?
30.
30 degrees. All right, so now what you're supposed to do is go, wow. Okay, that's what you're supposed to do. Everybody goes, wow, right. For the sine of 150 degrees, it has a reference angle of 30 degrees. And what has happened is really this little angle has been used over here, and we're extending our definition of our trig function. When we need the sine of 150 degrees, we're going to go to this little reference triangle, which we can draw with respect to the x-axis. And it is basically that the sine of 150 degrees will be equivalent to the sine using this reference triangle. And so this, if I didn't know 150 degrees because of my calculator, I would notice that's a 30-degree angle. This side is the opposite over adjacent. If it's a 30 degree, it would have to be a half, 0.5. Okay? All right. let's go a step further. Let's go to sine of 210. Sine 210. What'd you get this time when you did sine 210? Negative 0.5. The sine of 210 is negative 0.5. All right, well, let's see why we think this is negative 0.5. All right, this big angle is 210 degrees. So to help us identify what it is, we're going to come up with the reference angle, which is always with respect to which axis? X. And from that angle, I'm going to make a little reference triangle. So if this big angle is 210 degrees, what is going to be the measure of my little theta r right there, the reference angle? Remember, if you go all the way to the negative x-axis, you've gone 180, but all the way to that terminal side is 210. So 210 minus 180 is a 30-degree reference angle. 30 degree. All right, so this little reference angle is 30 degrees. So we know the ratio of the opposite to the hypotenuse is a half. Somebody needs to tell me where in the world you think this negative's coming from. Where do you think that negative is coming from? I'm in my coordinate system. Isn't that a y direction? It's like if you were plotting a point down here, wouldn't your y value be negative? So it's having to use the fact that you're in the third quadrant. Your y values are negative, so your sine, S-I-N, is going to be negative in this quadrant. Okay? Does that help? Not yet? Okay, let's keep going. Let's go sine of 330. The sine of 330 degrees. Where's the terminal side? So the angle in standard position, where's your terminal side going to be? Quadrant 4. All right, this represents 330 degrees. 330 degrees. All right, so here's the terminal side of this angle. All right, let's punch it away in the calculator and see what you get. Sine 330. You got negative 0.5 again. Negative 0.5. All right, let's see where this is coming from. Here is my little reference angle, because a reference angle is an acute angle that's always with respect to the x-axis. So if you went all the way around, you would be at, what, 360 degrees? But we're going to stop at 330 degrees. So the measure of your reference angle is 30 degrees. All right, I'm setting up a reference triangle. A reference triangle. And this little angle right here is 30 degrees. I'm using this little reference angle to help me out. Somebody needs to tell me why it's going to be negative. Because your y value is negative. The opposite is in the negative direction. Negative over hypotenuse. Okay? How's that, everybody? All right, I then ask you to look at sine negative 30 degrees. Where's that terminal side? Angle in standard position, where's the terminal side? Yeah, a negative 30 degrees is this direction, right?
Yeah.
Negative direction, negative 30 degrees. Okay, a reference angle is always between 0 and 90, positive. So even though this is a negative 30 degrees, my little reference angle is still 30 degrees. And I still see the opposite is negative, the hypotenuse is always positive. So I expect this to be negative 0.5 when I punch away in my calculator. All right, so let's put in sine, and I'll use parentheses, minus 30 degrees. And presto, there is negative 0.5. And that's because it was a negative direction, and my opposite in this negative direction was a negative sign. How are we doing? We'll keep going. This is not trivial.
You know how when they draw the little quadrants, it'll be like A, S, T, C.
Right.
Is that where that derived
Yep,
from?
it is, and we'll get there. Don't let me forget to get there. Okay? All right. Suppose I had the sine, asked to find the sine of negative 330 degrees. Sine of negative 330 degrees. Where's the terminal side going to be? In the fourth. Is it? Negative 330? In the first. Because this is negative 90, negative 180, negative 270, negative 330. Okay? Represents negative 330 degrees. All right. So let's put in our little reference angle. What's the measure of my reference angle? It's not a trick question. What is it? Well, if you went all the way to here, that's negative 360. So the difference between negative 360 and negative 330 is just 30 degrees. Okay, if you're in the first quadrant, is your opposite going to be positive or negative? Is that positive or negative? Positive. So if I put this in my calculator, I'm going to expect that to be positive 0.5. All right, so let's just put it in here. The sine, parentheses, negative 330 degrees, and there's your positive 0.5. Okay, so whether your trig function is negative or positive determines the quadrant that you're in. Is determined by the quadrant you're in, the terminal side for your angle. Okay. All right. Let's work on some cosines. Cosines. And let's work on 60 degrees. Okay, we want to look at the cosine of 60 degrees, cosine of 120 degrees, cosine 240 degrees, cosine 300 degrees. Okay? By the way, what's the radian measure for 60 degrees? Remind me. Pi over 3. All right. If we want to put in radian measures, it's pi over 3. 60 degrees is the big angle, and the opposite's got to be the big number. So what is the cosine of 60 degrees, everybody? Cosine is adjacent. What is it? Now that would be sine of 60, 1/2. All right, 60 degrees, your terminal side is in your first quadrant. You could write it as 1 over 2 or 0.5 over 1, whatever the ratio is. All right, just confirming it on your calculator. We're working on cosines now. Okay, there's your 0.5. Okay. All right, let's go to 120 degrees. Oh, what I want to point out to you is, you notice when you're doing an adjacent, the adjacent side to your triangle's line along the x-axis. Adjacent is along the x-axis. When you were doing sine, S-I-N, you were thinking in terms of the y values. Opposites were your y values. Okay, so for 120 degrees, anybody know right away what the radian measure for that is going to be? Isn't it twice 60 to get to 120? What's it going to be in terms of radians? Pi over 3 is 60, so how do you do twice that?
Pi over 9.
2 times pi over 3, right? 2 times pi over 3. 2 pi over 3 would be 60 degrees. You could always go 120 times pi over 180, but I'm hoping that you're going to start to see pi over 3 represents 60 degrees, and if you want a multiple of 60, it's like twice pi over 3. Okay, so anyway, terminal side of 120 is over in the second quadrant, true? And so let's draw our little reference triangle. This is the 120 right here. What is the measure of this little reference angle in here? 60 degrees, because 120 plus 60 is 180, correct? All right, cosine is adjacent over hypotenuse. Your adjacent is always going to be on your x-axis from your reference angle. Isn't this the negative x-axis? So when we punch away in our calculator, cosine of 120 degrees, what am I expecting the cosine to be? Negative 1/2. Okay, cosine 120 degrees. There's your negative 0.5 right there. Are you seeing the relationship when we're looking at angles beyond 90 degrees? These are called general angles. All right, let's go to 240. 240, you're over in your third quadrant, 240 degrees. The reference angle is always with respect to what, everybody? X-axis. So this measure of that reference angle right there is going to be 60, because this is 180 plus 60 gives me that big 240. 180 plus 60 gives me the big 240. All right. So would you say that the cosine of 240 is going to be negative or positive? Negative, because you got a negative adjacent side. You're on the negative x-axis. So when I put this in there in the calculator, it should come out to be negative 1/2, because the angle, reference angle, is 60 degrees. And for a 60 degree angle, the cosine is 1/2. But because I'm over in the third quadrant, the adjacent side is negative. All right, so if you put in your calculator cosine 240, we get negative 0.5. All right, I want you to tell me, what is 240 in radian measures? Okay, he said 4 pi over 3. Why not 3 pi over 3? This was 1 pi over 3, 2 pi over 3, and why not 3 pi over 3? Yeah. 3 pi over 3 reduces to pi, right? So you got to reduce them. They got to be reduced to lowest terms. All right, so this is going to be 4 pi over 3. Or you could say 4 times 60. 6 times 4 is 24. 4 times 60. So you have your 4 pi over 3. Everybody hanging in here? Don't forget, this is fun. Okay? All right, 300 degrees. We're over in the fourth quadrant. There's 300 degrees. Okay, we're going to put in our little reference angle and triangle. And we know all the way around would have been 360, so this is a 60 degree reference angle. Is my adjacent positive or negative here? Positive, right? You're along the positive x-axis. So we know this is going to come out to be positive 1/2. Okay, let's put in cosine 300. And there's your positive 1/2, positive. It's because your adjacent side to your reference angle is along the positive x-axis, positive 1/2. If you said 5 times 60, you're at 300. That's the same thing as cosine of 5 pi over 3. Okay, 5 pi over 3. Alrighty, let's do a drill. I got more to do, but I'm telling you a lot of things at one time. Let's do a drill on whether it's positive or negative. The trig function is positive or negative. That's all we're going to do at the moment. Do I need to keep it here another second? Okay. Don't forget, this is fun. I can't look at y'all's faces until. Yes?
I'm not getting negative like half when I'm trying to find cos 2 pi over 3. It's cos 120.
For this one?
Yeah.
Okay, you're not getting negative 1/2 when you put 2 pi over 3 in your calculator?
Cos, yeah.
Okay, let me do it. First of all, you have to go to radian measure for your angle, because if you put 2 pi over 3 in your calculator, it thinks degrees because you're in degree mode. So you go to your mode, and let's switch it down to radian mode. Okay, so I got to be in radian mode if I'm using 2 pi over 3. I really appreciate that you asked this. All right, so I'm going to do cosine parentheses 2 pi divided by 3, and there's my negative 0.5. You got to be careful the mode you're in. If it is a degree mode, degree for your angle, you definitely have to be in degree mode. Okay? Just because it's got the pi in it, the calculator doesn't know that that means radians.
2 pi over 3.
Yeah, she wanted to go back up to where we had cosine of 120, and she was not getting positive, and she was not getting negative 1/2. And I alerted her that you have to go into the mode of your calculator and switch to radians. Whenever you're going to put in the angle in radians, you have to be in radian mode. All right, let me switch out because most everything we're doing is in degrees. Okay, everybody good so far? Right. When you're working with radian measure, you don't see a little degree symbol there. You got to go to your radian mode. But when you see the little degree symbol on your angle, you got to be in degree mode. Okay? Everybody good so far? All right. All we're interested in this little drill is the sign, S-I-G-N, positive or negative. Okay? All right, I'm going to set up a coordinate system. This is the x-axis and the y-axis. Okay? And the first one I'm going to work with is, we're just going to work, don't look back, let's just try to think. We're going to work with cosine of the angle. Cosine. If you hear cosine, you're thinking, what's the definition? When you have cosine of an angle? Adjacent over hypotenuse. Hypotenuse is always positive. So when you're working with trying to determine if the cosine's negative or positive, you're only worried about the adjacent side. And no matter what angle you're with, your reference angle, the adjacent side will always be along the x-axis for cosine. So if you're in your first quadrant, your cosine is always positive. If your terminal side is in your second quadrant, some angle, terminal side in the second quadrant, your cosine will always be negative. If your terminal side is in the third quadrant, your cosine will always be negative. If you're in the fourth quadrant, here's your little reference angle, your cosine will always be positive. Okay, if you know the cosine, what other trig function do you know right away? Secant. So secant's going to follow the same negative and positive as the cosine. So in the first and fourth quadrants, first and fourth, your secant is going to be positive. In the second and the third quadrants, your secant will be negative. Okay? Secant because it's the reciprocal of the cosine. And cosine you thought adjacent. Okay? Everybody got it? All right, let's look at sine. S-I-N. Okay, the question is, what is the S-I-G-N? Is it positive or negative? And we're going to look at the trig function sine theta. Okay, and let's just start with a theta in the first quadrant. When you think sine, the words are opposite over hypotenuse. Now the hypotenuse is always positive for our little right triangles. The opposite, you're thinking in terms of y values, because that's a vertical, okay? So if you're in your first quadrant, your sine is positive. What other quadrant has a sine positive? Second, because if you're over here, your y value is positive. So your sine is positive in the first and the second quadrants. If you know sine, what other trig function do you know? Cosecant. So your cosecant is also positive in the first and second quadrant. Okay, what's my sign going to be down in the third or the fourth quadrant? Negative, because you have negative y values. All right, everybody getting it? Sine, you're thinking opposites, those are verticals, those are y values. Cosines, you're thinking adjacent, those are x values. Okay? All right, now let's think tangent. Is the sign positive or negative for tangent theta? All right, now tangent, aren't we thinking sine over cosine or opposite over adjacent? I don't know which way you want to think. Do you want to think sines and cosines or opposites over adjacent? Like opposite over adjacent? Okay, so in order for a tangent to be positive, if you need a tangent to be positive, that means that both the opposite and the adjacent have to be positive, or what else? How do you get a positive number? They're a fraction to be positive, both positive or both negative, right? Okay, so which quadrants are going to have positive tangents? The first one, and where else? Where are you going to get a negative opposite and a negative adjacent? Yes, because you got negative adjacent, negative opposite. So this is where your tangent is positive. And then in the second and the fourth quadrant, you're going to have tangents that are negative, because over here you've got a negative adjacent even though you got a positive opposite. If you're in the fourth quadrant, you got a positive adjacent but a negative opposite. Okay, I'm almost scared to ask you this for you people who've had trig. There's a little saying. I don't know what your saying is. You come up with some weird ones sometimes. What? Okay, what's your saying? All students take calculus. All right. What that means is just consider the trig functions sine, cosine, and tangent. Is that true? Okay, of these three, in the first quadrant, all are positive. We're just looking for which are positive. Which are positive. So the all right here, the A means sine, cosine, and tangent are positive. Of course, if sine, cosine, and tangent are positive, then cosecant, secant, and cotangent are also positive. Okay, the S for students here says that only the sine of those three is positive. And you see that's because you got a positive y value. Your adjacent is negative. So your cosine's negative as well as your tangent is negative there. T for the take is only the tangent is positive in terms of sine and cosine and tangent, because you got a negative cosine, negative sine. Okay, and in the fourth quadrant for the word calculus, it's only the cosine is positive, because you got a negative sine, which makes you have a negative tangent. Okay, everybody good? All right, let's see if we can put this all together. By the way, let me point to you in the book, section 6.4. I think I forgot to mention the objectives here. Find the exact values of the trigonometric functions for general angles. That was what we were doing when we went with 120 degrees or 330 degrees. We were finding some exact values. Use coterminal angles to find the exact values of some trig functions. We haven't talked about what the word coterminal means yet. We'll get there in a second. Determine the sine of the trig function of an angle in a given quadrant. That's where we just used all students take calculus and tried to show you how that was going around. Find the reference angle of a general angle. So we'll find the terminal side of an angle in standard position. We'll draw that reference angle with respect to the x-axis. using a reference angle to find some exact values. We just did a few of those. We're going to do some more. And then find the exact values of trig functions of an angle given information about the particular function. So we got a lot more drill to do. Okay, and on page 635, a little further down, especially the figure here, I think is pretty good. They're going to an angle in standard position, and they're trying to show you that for that big angle theta, using your reference angle, you just have a whole bunch of similar triangles that are in the ratio of like opposite over hypotenuse or adjacent over hypotenuse. And they give you actually, if you're calling these A's, B's, and R's, over on page 635, they're giving you all these definitions. However, I think if you just have already memorized that tangent is opposite over hypotenuse, you're going to be better off to just draw your little reference triangle and do your opposite over hypotenuse, etc. Okay? All right, so let's work a problem. Actually, I noticed my time's about to run out. We're going to start out the next lecture working some problems out of these exercises. Okay? All right, take a break and enjoy. At people's feet, and you heard every problem they ever had. Alrighty, welcome back to Math 107, and we're at Lecture 18B, and we're still working on Section 6.4, which is not included on Test 3, but on the final exam. Okay, but I think this is very helpful for practice with your exact values, etc. Okay. We had just finished talking about in which quadrants do you find your trig functions to be positive, and we'd use the word the little sentence, all students take calculus. If you're in your first quadrant, all three of your major trig functions are positive. Second quadrant, only your sign because your adjacent is negative, but your opposite is positive. And your tangent is positive in the third because your adjacent and your opposite are both negative. Negative over negative is a positive. And then your cosine is positive in the fourth because you've got an adjacent there that's positive. The sign is negative, S-I-G-N, because your opposite is negative. All right, let's see if we can put all this together and make it work. All right, given that the tangent of theta is equal to 3 and 180 degrees is less than theta, less than 270 degrees. We want to find, and by the way, theta is an angle in standard position, and a lot of times you're not told that, we just kind of assume it, but theta is in standard position. I'm off the page. Thank you. Theta is in standard position, and we're given that the tangent of angle theta is equal to 3, and that the angle theta is, the measure of angle theta is between 180 and 270. We want to find the sine of theta. We want to find the measure of angle theta. Okay, this part's new. Actually, maybe all of it's new to this exercise. All right, so let's get a visual. We have an angle theta in standard position. We know it's somewhere between 180 degrees and 270. So we'll put it over here in the third quadrant. Here's our angle theta. Okay? All right, we know that the tangent of this angle theta is 3. So to help us, we're going to put in our little reference triangle. Use reference triangle. All right, where do I find my reference angle, everyone? With respect to the x-axis. So here's going to be my little reference angle, and here's my little reference triangle. Okay. Now remember, this is little theta r. That's my little reference angle. We really are talking about the tangent of the big angle theta. All right, now for this big angle theta, the tangent is equal to 3. And we define tangent to be opposite over adjacent. So the tangent of theta is the opposite over the adjacent. And that's equal to 3, which you might want to write as a fraction 3 over 1. But if your opposite is right here, is that going to be negative or positive? Negative, because you're in the third quadrant. So we're going to write that as negative 3 over negative 1. My tangent's still equal to positive 3, my given problem. But if we're over here, the opposite would have to be negative 3 and the adjacent negative 1. Okay? Now, once we've set up our triangle, we need to figure out the hypotenuse so that we can get the sine of the big angle using our little reference triangle. All right, so we'll use our good old Pythagorean theorem to find the hypotenuse. Negative 1 squared plus negative 3 squared equals r squared, c squared, whatever you want to call it. 1 plus 9 is equal to r squared, so r is going to be, what, square root of 10? Square root of 10. Okay, the question is to find the sine of this big angle theta, but we use our little reference triangle to give it to us. So using our little reference triangle, the sine is what, everybody? The sine is use your little reference angle, opposite over, yep, negative 3 over square root of 10. Okay? All right, now once we find out this big angle, we'll come back and do some approximations with our calculator to show that you are correct. Okay? Let's just go a little further while we're right here. We just saw that the sine of the big angle, but using our little reference triangle, is negative 3 over the square root of 10. What's the cosine of the big angle theta equal to? What's the cosine of this big angle using your little negative 1 over square root of 10? Everybody good? And we know that the tangent, we were given that, is 3. All right. Now the next question becomes, what is the measure of angle theta? To find measure of angle theta, first find the measure of the reference angle. This is going to be very important because the inverse trig function we're using, we just want it to give us an angle between 0 and 90, and that will be the measure of the reference angle. Then once we know the measure of the reference angle, we'll be able to find the measure of the big angle. Okay, so first thing we want to do is find theta reference, the reference angle. All right, so let me just redraw our little reference angle. I'm just copying it off here. This is my little theta r right there. This side is 3, this side is 1, and this is square root of 10. Now, for the reference angle, because this has got to be a little positive angle between 0 and 90, I'm only going to use the positive lengths here so that I get the measure of that angle. All right? Remember, a reference angle is an angle between 0 and 90. Therefore, I have to use all positive values to come up with it. All right, so which of these trig functions is clearly the easiest for coming up with a measure for the reference angle? Tangent's the easiest one, right? So we're going to do the inverse tangent of 3 is going to be the measure of our reference angle.
71.565.
Good, you're ahead of me. I am very happy for you. Happy that you did that. Let me just, did you get 71.56? Okay. So the measure of the reference angle is approximately equal to 71.5, looks like it'd be about 0.57 if I'm just going to round to 2 decimal places, degrees. Everybody good? Okay. Now the question though, this little reference angle right here is about 71.57 degrees, but I'm interested in the measure of the big angle. So if I know this angle right here is 71.57, how do I find the measure of the big angle? Yep, because if you go all the way to the x-axis, you've gone 180 plus 71.57 more. So we will say 180 plus the measure of the reference angle. Okay, and it is approximately 251.57 degrees. Okay, is the measure of this big angle. All right, I told you we would do a little check just to be sure. A little check. Let's get the decimal approximation for -3 over the square root of 10. So we'll be able to see it in the calculator. -3 divided by square root of 10. That comes out to be approximately 0.9487. I'm just doing it so that I'll know what that was. Okay. All right, so we're claiming the measure of the big angle is 251.57. So let me make sure I'm in the correct mode of my calculator, degree. And I'm going to look at the sine of 251.57 degrees. And that should come out to be pretty close to -0.9487. And there it is, -0.9487 whatever. And if I look at the tangent of 251.57 degrees, that should come out pretty close to 3. And it came out to be 3.00086. And I'm off due to rounding this angle a little bit. Okay, everybody doing good? All right, let's try another example. Okay, given that the terminal side of angle theta passes through the point -2, 5. This angle is in standard position. It's just going to be a given that it's in standard position. Given that the terminal side of angle theta passes through the point -2, 5, find the sine of theta, cosine theta, tangent theta, and the measure of angle theta. Okay, so this question is a little different. We have an angle in standard position. It's going to pass through the point -2, 5. And we're going to be interested in finding the sine, cosine, and tangent of this angle, as well as the measure of the angle. All right, let's get a visual on this. Let's just draw this on blue so we can keep coming back to it. Here's the positive x-axis and positive y. And the point -2, 5 should be somewhere like right here. And it says your angle is in standard position, so the initial side's along the positive x-axis. Gotta let my marker dry out. And the terminal side passes through this point right here. Okay, so here is my big angle theta. Okay? All right. So if it's passing through this point -2,5, how am I going to come up with what the value of the sine and the cosine, etc. are? What do you think? Say it again. Exactly. If you know a point on here, you could drop your perpendicular straight down and you will have your little reference triangle. This little angle right here is your reference angle. And what would be the x value along here? Is it +2 or -2? -2. And the y value is +5. And what's the hypotenuse? Do it in your head. What's the hypotenuse?
No. Square root of 29.
Square root of 29. Using the Pythagorean theorem, 4 plus 25, 2 squared, 5 adding 2 squared plus 5 squared equals c squared, square root of 29. All right.
So then theta is in the bottom right-hand corner.
The reference angle is down here,
Okay.
but the question is really about this big angle theta that's
Okay.
right there. Okay, so let's answer some questions. What is going to be the sine, S-I-N, of that big angle theta? And everybody says, what's the sine of the big angle theta using your reference triangle to help you? 5 over the square root of 29. Okay. Opposite over hypotenuse. What's the cosine? -2 over the square root of 29. -2 over the square root of 29. And what is the tangent of this big angle? 5 over -2. You can put the negative anywhere. -5 over 2 or 5 over -2. All right, everybody seeing that? Is that easy? All right, now let's do the part that's not always so trivial. You didn't think that part was trivial? All right, now we want to find the measure of angle theta. All right, to find the measure of angle theta, what did we just say you need to work with? To find the measure of angle theta, first, find the measure of the reference angle, which is the angle between 0 and 90. All right, so in order to do a 0 to 90, you're just going to make your little reference angle, but make all the sides positive. Okay, so there's my little theta. This is now a 2, a 5, and a square root of 29. Okay, all I did was pick up this little reference angle, redraw it with positive sides because your theta r is always between 0 degrees and 90 degrees. So I need to make all those positive to come out with an acute angle. All right, so which trig function is going to be the easy one to work with? All of them should be easy, but if you don't have to put a square root in, life's a little easier, right? So for our theta reference, let's use that the tangent of the reference angle here is 5 over 2. So your question is, what is the angle? And as soon as you hear what is the angle, everybody's thinking inverse tangent, 5/2. Okay, make sure you're in degree mode. Inverse tangent, parentheses, 5 divided by 2. And theta reference is approximately equal to 68.2. It's going to be pretty close. If you round the 2 decimal places, for sure it's 0.2. If you're going to go to 2 decimal places, it's still 0.2. All right, we'll just go about 68.2 degrees. Okay, but that wasn't the question. The question was, well, what is the measure of this big angle theta? And if you know this little angle right here is 68.2, what are you going to do? Minus by 90. 68.2 from 90. Don't write this down. 8, 1 and 8 is 9, 6, 2, 21.8. Let's see if the tangent of 21 point, wait a minute, did you say add to 90 or subtract to 90?
Subtract the 90 to get that particular half, and then you add 90 to get the whole angle.
So if you say 90 minus 68.2, that gave you this little part right here.
And you add 90 to get the whole angle.
And then if you add, okay, so I'm just going to follow your logic here. So this would be 21.8, and if you add 90 to 21.8, that's going to throw you down here.
No, that quadrant. The first quadrant will give you 90, and then you add.
Oh, okay. All right, now I see what you're saying. 90 plus 21.8. Okay, that's a 2-step problem you got there. You're okay. All right, let's look at another way. That's not the tradition way to do it, but that's fine. All right, tradition would have it that you always work from the x-axis, so you only have 1 step to do. And you know if you go all the way to the x-axis here, that's 180 degrees, but you pull off the reference angle, so 180 minus 68.2, 111 degrees, 0.8, and that's the same thing as what you were just saying. Add your 90 to it. You got it. You just did it in 2 steps, and you're fine. Took me a second, though, to follow. Sorry. All right, so the measure of your big angle is about 111.8 degrees. Everybody good? All righty. So we're doing some general angles. How are we going to deal with something like the cosine of 90 degrees and the sine of 90 degrees without punching away in our calculator? All right, let's see where we are on the coordinate system. If I'm at 90 degrees, I'm right here. Any point on the positive y-axis. And to get to this point, and you can pick any number you want to. I could pick 0, 1, I could pick 0, 2, I could pick 0, 5, any number I want to call that. That would be, the terminal side would be the positive y-axis. And if I want to know the cosine and sine of this, and we've done everything in terms of opposites, adjacents, and hypotenuses, if we were trying to figure out how we're going to do adjacent, remember x is adjacent. So if we do a 0, 1, the adjacent side is going to be 0 because you go over 0. And the hypotenuse, of course, would have to be 1. The cosine of 90 degrees is 0. How about sine of 90? Sine is the opposite. You're thinking of y value. And of course, if you did the Pythagorean theorem, 0 squared plus 1 squared equals c squared. If you're trying to think in terms of hypotenuse, c is going to be 1. Hypotenuse is 1. So if you're thinking in terms of sine of 90, the y value would be 1 over hypotenuse of 1. So the sine of 90 degrees is 1 over 1 or 1. What about the cosine of 180 degrees and the sine of 180 degrees? Okay, 180 degrees sends you all the way to the negative x-axis. I can put any number I want to on here. I'll just pick an easy one like negative 1, 0. All right, so if you're trying to think in terms of some little triangle, the hypotenuse, it would be -1 squared plus 0 squared equals c squared, or c is going to be 1. Okay, a cosine, aren't you thinking adjacent? That's an x value. What's the adjacent? -1 over hypotenuse. So the cosine of 180 degrees is -1. You can punch away in your calculator and verify that. What about the sine of 180? Sine, that's your y value. 0 over your hypotenuse, or 0. Is everybody getting it? Everybody got it? Well, we have looked at angles within the quadrants, and now what I'm really trying to do is show you the trig values when you are actually on a quadrant, on an axis. What about if you're at 270 degrees? 270 degrees. You're looking at the angle 270 degrees. I can just pick any point I want on that. 0, -1 is the easiest one to pick. If I'm trying to think in terms of a triangle, which couldn't have a side length 0, but the hypotenuse would have to be 0 squared plus -1 squared equals c squared, or your c is 1. Okay, if you want to talk about the cosine of 270 degrees, the cosine of 270 degrees, your adjacent is always your x value over your hypotenuse, or 0. Punch away cosine 270 in your calculator, you're going to get a 0 there. If you want the sine of 270 degrees, sine, you're thinking of your opposite, your y values, and you would have -1 over 1, or -1. So if you put it in your calculator, sine of 270, there is your -1, that's right there. Okay? So the idea I was trying to bring across is when we were looking at cosines, we were always looking at adjacent sides, which are x values over the hypotenuse. Well, when you're on the x or the y-axis, you can't really have a triangle because one leg would have to be a 0. But you could still go back to the definition of your general angles, where they did the A's and the B's and the R's, or you can think in terms of cosine being an adjacent x value and sine being an opposite y value, okay, to help you visualize what those trig functions are. All right, I think that is pretty much going to cover what is in 6.4, so let's go to the exercises and make sure I did cover everything. Okay, I'm in page 644. 644, and we're looking at number 20. Okay, I'm on page 644 in the exercises, and I'm looking at number 20. Let's see if I can find number 20. Oh, by the way, let's look at some of the problems, and you'll see we've already done them. Problems 11 through 20, it tells you the point is on the terminal side of angle theta. Find the value of the 6 trigonometric functions. We just did those. Oops, number 20 was one of those, so let's do it. Number 20, you've got the point -square root of 2 over 2, -square root of 2 over 2, and I'm going to go a step further, and please mark that in your book because I'm going to ask you these kinds of questions. I want to know the measure of angle theta. All right, the terminal side passes through that point. Where's the terminal side going to be for these that passes through this point? Which quadrants? Quadrant 3. Okay, it's going to pass through the point -square root of 2 over 2, -square root of 2 over 2. Somebody tell me right away what the measure of this reference angle is without any effort. It's a 45-degree reference angle. How do you know? Right, the sine and cosine of square root of 2 over 2, sine and cosine of 45 degrees is square root of 2 over 2. So that's one you've memorized. All right, so this is a 45-degree reference angle. Okay, the question asks for, by the way, what would be the hypotenuse here? If this is a negative square root of 2 over 2 here, a negative square root of 2 over 2 here, what's the measure of this hypotenuse? 1. If you say minus square root of 2 over 2 squared plus minus square root of 2 over 2 squared, this will give me 2 over 4 plus 2 over 4, which is 4 over 4, which is 1. So C would be equal 1. Your hypotenuse would be equal to 1. Okay, what is the tangent of this big angle theta? What's the tangent? 1. Opposite over adjacent. But the tangent of a 45-degree angle or reference angle all the way is always going to be positive 1. All right, you just told me the measure of the angle, reference angle, is 45 degrees. What would that be in radian measure? Pi over 4. Okay, what is going to be the measure of this angle theta in degrees? What's going to be the measure of that angle theta in degrees? 180 plus 45, and that is 225 degrees. I want to know what is angle theta in radians.
Pi plus pi over 4.
All right, the first thing I think I heard you kind of do was all the way to here is pi, and if you got a common denominator, that is 4 pi over 4. He's getting it in terms of 4 pi and 4 pi over 4s. So pi is the same thing as 4 pi over 4, and that's another pi over 4 right here. So in terms of radian measures, that is 5 pi over 4. 5 pi over 4. Yes. Yes. You have memorized, hopefully, that 45 degrees is pi over 4. If you wanted to, if you knew this was a pi over 4 reference angle right here, and you wanted to find the measure of the big angle, you know that all the way to the negative x-axis is pi, which is the same thing as 4 pi over 4. 4 over 4 is 1. So if you're at 4 pi over 4 and you add one more pi over 4, 4 pi over 4, and you're just going to add one more pi over 4, you will get your 5 pi over 4. Okay? All right, everybody good on number 20? If you know sine and cosine and you got tangent, then you've got your other 6 trig functions. Okay, let's look at problem number 22. Problem number 22. Oh, I haven't defined this term. Good thing we're going through this. Number 22. We're given the cosine of 420 degrees, but the instructions say use a coterminal angle to find the exact value of the cosine of 420. Do not use a calculator. All right, so let's flip back in the book so we make sure we see exactly what the definition of a coterminal angle is. And coterminal is defined on page 637. Page 637. We want to talk about angles that are coterminal. Two angles in standard position are said to be coterminal if they have the same terminal side. So if they're in standard position, they have the same initial side, they have the same terminal side, but the angle is different because maybe you went round and around or a negative direction. As long as you start with the initial side along the x-axis and you end up with a terminal side, you just go round and around either direction to end up back. Okay? Okay, coterminal, same initial, same terminal, but not necessarily the same angle. All right, so now let's go back to the exercises in 6.4. We have an angle of 420 degrees. Let's see where that is. All right, so I'm at my initial side's along the x-axis. I go all the way around, and I've gone how far? That's 360 degrees, correct? and I'm looking to try to get to 420. Let's see how much further I need to go. 60 degrees more. So I'll just continue this on 60 degrees more, which would be somewhere like right there. And now this angle right here, represents 420 degrees. Okay, my terminal side is right here. Okay, so what angle is going to be coterminal with 420? There's a lot of coterminal angles. You just go round and round forever and ever and ever. But we're wanting to get it where we can figure out the value of the cosine. So my initial side's here. My terminal side's here. What little angle are you going to use as coterminal to help you find the cosine? 60 degrees. So the cosine of 420 is going to be equal to the same as the cosine of 60 degrees. Okay, and it said don't use a calculator, but we'll sort of verify it with a calculator. All right, 60 degrees is one of those special angles you've memorized, right? 60 degrees is a big angle. So you know the side opposite is the big one. So the side adjacent is going to be little. What is the little number? 1/2. All right, so let's just verify on the calculator we got it all correct. The cosine of 420 degrees is a positive 0.5, and we already knew the cosine of 60 degrees was 1/2. Okay, so we used a coterminal angle. And so what you're trying to do is get it down to really an acute reference angle to help you out. All right, everybody good on that?
Basically, just trying to find the reference, the terminal angle. Is that what they're asking?
They're asking you to use a coterminal angle, which would be a little smaller angle, to help you find the exact value of the cosine of 420. So coterminals just mean you have same initial side and same terminal side. And actually, you know, you could have another angle that goes all the way around and around and around and around. But as long as they stop with the same terminal side, you'll be able to find the cosine very easily using 60 degrees. Okay? All right. Yes?
Isn't there a way you can just, like, for like number 21,
Mm-hmm.
can you just subtract it from the nearest terminal angle or something?
Okay. All right, so tell me what you're wanting to do.
Like, isn't there a way to just subtract something without having to actually draw it out?
Okay. What would you like that
Like,
something
when you
to be?
subtract maybe 360.
360. Whenever this angle is bigger than 360 degrees, that's a very good place to start. So start at 405 degrees, subtract 360 degrees, and you are at 45 degrees. So the sine 405 degrees is this angle,
Okay.
but your coterminal angle is going to be a nice little 45 degree.
Okay.
And so what's the sine of 405 degrees, everybody? Exact value. Square root of 2 over 2, because it's the same as sine of 45 degrees.
Okay.
Okay, is that good?
Mm-hmm.
All right. Number 34, let's see what that is. All right, number 34 says, name the quadrant in which this angle theta lies. The information we have is that the sine is negative and the cosine is positive. Sine is negative, cosine is positive. All right, let's think about it. Sine is negative. Cosine is positive. All right. Which two quadrants have a negative sign, S-I-N? Where's the sign negative? Are you thinking X's or Y values for sine? Y, because sine is opposite. Okay, So which quadrants have negative y values?
Third and fourth.
Third and fourth. Okay. Cosine is positive. Cosine, you're thinking adjacent x's. Where do you have positive x's? First and fourth. What you needed was both of these to be true. And so you would pick quadrant 4. Everybody see how that works?
Can you
All right.
explain that again?
Yes, I will. All right. When you're thinking sine, remember sine is opposite over hypotenuse. And when you set up that reference triangle, the opposite is the y value for your reference triangle. Your hypotenuse is always positive, so you don't have to worry about that. So sine being opposite, whenever you draw your little reference triangle, your opposite is with respect to the y value. So your sine is negative wherever your y values are negative, which would have to be third and fourth quadrants. Cosine, thinking in terms of the words adjacent over hypotenuse, whenever you draw a little right triangle, the adjacent is along the x values. So where are your x values positive? Well, your x values are positive for anything in the first and fourth quadrant. So the question becomes, in which quadrant would an angle that has a sine negative and a cosine positive lie? And you would have to say fourth quadrant. Okay, now the way some people do it, they would start with x, cosine x. They go positive cosine, and they would go this direction. And then negative sine, this direction. Bingo, you're there.
And what about like all students take calculus? You could use that.
You could take, yes, you could do all students take calculus. That would mean that your cosine, since both of them are not positive, it wouldn't be here. This is where your sine is positive, so it wouldn't be here. The only one that's positive here is tangent, but this one has cosine positive only, and that means your sine would be negative, so you could use that. Okay? Everybody good? All right, what number was that? Number 34? Okay, let's go to number 44. Number 44. Find the reference angle. Ooh, that's going to be easy. 300 degrees, and we're just looking for the reference angle. I bet you already know without any effort. What is it? 60. All right. Where's the terminal side of 300 degrees? Fourth quadrant. Remind me what the negative y-axis is in your degree if it ended on the y-axis. That's 270 degrees, right? Mm-hmm. And all the way around the x is 360. All right, 300 degrees. Your reference angle is always with respect to the x-axis. So if all the way here is 300, all the way back to the positive x-axis is 360, your reference angle is 60 degrees.
Do we have to show like working for that?
The working for that would be just right there. The more work you show, the more partial credit you can get if you happen to miss it. I mean, if you subtracted wrong or something. Okay, what about if you have something that is like 2 pi over 3? Can you look at this and tell me right away what the reference angle is going to be? It is 60 degrees, but in radian measures, what is it? Okay, these are the easiest ones to look at. If you wanted a reference angle for 2 pi over 3, this is the same thing as 2 times pi over 3. So pi over 3 is the reference angle. And what's the degree measure for pi over 3 quickly? 60 degrees. So this would be a 60 degree reference angle, or pi over 3. Suppose you had 5 pi over 3. What's the measure reference angle for that? These are easy. These are not trick
Pi over
questions.
3.
Just read it right off. Pi over 3. Suppose you had an angle 7 pi over 3. What's your reference angle?
Pi over 3.
Pi over 3 is your reference angle. Suppose you have 4 pi over 6. What's your reference angle? Wrong.
Pi over 3.
You have to reduce these to lowest terms before you can get to the reference angle. So this is 2 pi over 3. Now what's the reference angle? Pi over 3. All right. 4 pi over 6 reduces to 2 pi over 3, so you got a 60-degree reference angle there. All right, everybody got that? All right, so we're on number 54 now. 54. Well, that one was too easy. Number 54. It is finding the reference angle for negative 7 pi over 6. I want to know where the terminal side of negative 7 pi over 6 is. I want to know where the terminal side of negative 7 pi over 6 is. Where is it? This negative, which direction are you going? Okay, so that 7 pi over 6 is more than 6 pi over 6, right? So let's go over here to pi and write that as negative 6 pi over 6. Isn't that true? Why am I using 6 pi over 6? Because there's a 6 in the denominator there. So where's the terminal side of negative 7 pi over 6? Which quadrant? That's negative 6 pi over 6. How far do I go now? Another negative pi over 6. And here is negative 7 pi over 6. Pi over 6 is how many degrees? 30. All right. All right, so this is, if you wanted to call this negative pi over 2, negative pi over 2 right down here, you could always write that in terms of 6 as negative 3 pi over 6. So you have like negative 1 pi over 6. Negative 2 pi over 6 reduces to pi over 3, so there's your 60 degrees. Negative pi over 2 is the same thing as negative 3 pi over 6. A negative 4 pi over 6 would reduce. Negative 5 pi over 6, negative 6 pi over 6, and one more negative pi over 6 gets you to negative 7 pi over 6. Okay, question number 54 is, what is the reference angle? Reference angle is always some little positive angle with respect to the x-axis. That's going to be easy. What is the reference angle? 30 degrees, but since this is in radian measure, pi over 6. So what is the measure, by the way, in degrees? Negative 7 pi over 6 in degrees is what? Okay, so you got negative 180 plus a negative 30, because pi over 6 is 30, negative 210 degrees. Exactly. Okay, does everybody see how you're counting these? All right, that was number 54. Let's go to number 72. Number 72 is use the reference angle to find the exact value. All righty, this is going to be good. Cosine of 2 pi over 3. All right, the instructions are exact value. That means stay away from the calculator. All right, which quadrant is the terminal side in? In this pi right here, which is 3 pi over 3. What's the reference angle? Pi over 3. So if you're pi over 3. If you're wanting to convert these to degrees very easily, pi over 3 is how many degrees?
60.
60 degrees. And this is twice times pi over 3, so how many degrees is that?
120.
120 degrees. So 2 pi over 3 is right here. Okay, your reference angle is 60 degrees. if you're over in this quadrant, is your cosine negative or positive? Negative. Okay, if you're using your 60-degree reference angle, what is going to be the cosine of 60 degrees? Okay, the cosine of 60 degrees is a half, and it's negative because we're really looking at the cosine of the big angle, 2 pi over 3, negative 1/2. And you can check that by just looking at the cosine of 120 in your calculator, and it'd be negative 1/2. Okay, I saw a confused look, so let's back up. They're giving it to you in radian measure, which is really the very easiest to work with, because if it's reduced to lowest terms, you immediately can find your reference angle. And pi over 3 is 60 degrees. And this is 2 times pi over 3, so the measure of this angle is really 120, which meant that was a 60-degree reference angle. And that is one you've memorized. If you're over here, your adjacent is negative, because you're working with cosine. And the cosine of 60 degrees is a half. Okay? Isn't that fun? Aren't you having a great time doing that? All right, let's look at another problem. Number 80. Number 80. Number 80 is asking for the secant of 11 pi over 4. Secant of 11 pi over 4. All right, first of all, we're not going to let secants bother us because we're going to translate it to one of those 3 trig functions that we're comfortable working with. So this is 1 over the cosine of 11 pi over 4. All right, let's see where we are. Pi is the same thing as 4 pi over 4. If you go all the way around to 2 pi, and you wanted to get it with a common denominator of 4, that's the same thing as 8 pi over 4. All right. So where's this angle going to end up that's 11 pi over 4? Negative y-axis?
No, it's in the first quadrant.
All right, 8 pi over 4 plus 3 pi over 4. Wouldn't that be equal to 11 pi over 4? I wanted to get us all the way around to get to 8 pi over 4, which is 2 pi. And I'm trying to find out what 11 pi over 4 is. It looks like I'm going to have to go 3/4 of a pi more, which will send me to over here. All right, so that big angle there is 11 pi over 4. All right, let me say that again. If you go all the way around, you've gone 2 pi, which is equivalent to 8 pi over 4. So you could say 11 pi over 4 minus 8 pi over 4 leaves me with 3/4 of a pi. Pi is the x-axis, so 3/4 of that would be over to here. All right, so the angle's right here. What's the measure of the reference angle? That part's easy. What's the measure of the reference angle here for 11 pi over 4? Pi over 4. Reference angle between 0 and 90. 90 is pi over 2. All right. If you're in this quadrant, is your cosine going to be negative or positive?
Negative.
Negative. So it's 1 over minus. And what is the cosine of pi over 4? Square root of 2 over 2. So when we flip this over, it would be negative 2 over the square root of 2. And you could simplify that if you wanted to. All right, so what do you need to do? You need to find where is the terminal side, get your reference angle. If you know where your terminal side is, you know if your adjacent is negative or your opposite's positive or whatever, and then use your special trig functions. Okay? Alrighty, I'm just noticing the time, and class needs to be over in 1 minute and 5 seconds. All right, we're going to stop here. This is hopefully helpful for your test because you had to know your exact values of those acute angles. Tomorrow I'll take your questions for your test, and then we'll press forward. Okay, make it a great day, everybody.